Hi everyone, welcome back to geometry class. Today we're in chapter 1, section 2 of your textbook. We'll be talking about measuring the length or distance of segments. So grab your textbook, turn to page 13 and follow along. Also make sure to take notes or questions down that are important to you. Okay, so by the end of this video, you'll be able to answer the following questions. What is the midpoint of a segment? How is the midpoint used to find length? How is any other point in between the endpoints used to find length? And then finally, what is a segment bisector? Okay, so today we're going to be talking about length of segments, but I'm also going to be using the word distance to describe the length. Those two words mean the exact same thing, how long a segment is. Okay, the important thing I want you to remember is that distance or length is always positive. It's never negative. So let me give you an example. Let's say I'm at Springwoods High School and I'm hungry, so I hop in my car and I drive to Burger King at Long Point. Okay, well, it took me a mile to get from Springwoods to Burger King. Well, when I finish my burger, I get back in my car and I drive back to Springwoods. But it still took me 1 mile to drive back to school. So in either direction, it was 1 mile to drive. So distance is always going to be positive, no matter which direction you're going. Okay, so this time, let's imagine you're at Springwoods and your friend is at Burger King, and you decide you want to meet up with each other. But the problem is you hurt your foot over the summer playing soccer. So you're walking a little bit slower than your friend. So you meet at this point because your friend walked faster and farther than you did. Okay, so let's call this point C. All right, this point is in between Springwoods and Burger King. It's not in the middle, but it's just in between those 2 points. Okay, I can also represent the length between Springwoods and Burger King as a line segment, with A being where Springwoods is and B being where Burger King is, and point C being a point in between the 2 endpoints, A and B. Okay, great. I could also say the distance you traveled from Springwoods to point C and the distance your friend traveled from Burger King to point C is equal to the total distance from Springwoods to Burger King. So I could actually represent that here. The length of line segment AC plus the length of line segment CB is equal to the total length of line segment AB. Okay, so let's put some values to this. Let's say the length of line segment AC, or the distance you walked from Springwoods to point C, was 2 units. And the length from Burger King to point C, or line segment CB, is 8. Okay, well, all I want to do is add them together. I can add line segment AC, or 2, plus line segment CB, which is 8, and that would give me a total of 10. So the total line segment is just the sum of the 2 line segments put together. Great. This idea is called the segment addition postulate. Okay, let's stop here for a second and talk about what a postulate is. A postulate is something we accept is true. We don't need any other information to believe that it is true. So, with the segment addition postulate, I can accept that the length of line segment AC, when I add it to the length of line segment CB, is going to equal the total length of line segment AB. I don't need any other information to prove that. Okay, so please stop and write down your notes the segment addition postulate using this example. Great. Okay, so let's use the segment addition postulate to solve a problem. So this time, I've given you segment AC and segment CB, their lengths as expressions with variable x. Okay, so what I want you to do always is your first step in this type of problem is write down the 2 line segments that add together to equal the longer line segment. That's always step 1. Okay, now what we can do is plug in the expressions that represent each of the line segments. So line segment AC, we are given 2x as its length. Same thing with CB, we know it's 8x, and we know the total length is 20. Showing you the total length is 20. We do know that. Okay, so now what we can do is solve for x. So my next step is to collect the the common terms, the like terms. So 2x and 8x are like terms, so I can add them together, and that equals 10x. Still equals 20. My next step, I want to isolate the variable x. So what I'm going to do is divide by 10 on both sides. So when I divide by 10 on both sides, 10 cancels out on the left-hand side, and I get x equals 2. Great. Now I'm not finished with this problem because what I want to find is the length of line segment AC and the length of line segment CB. So what I need to do is plug x back in to solve for their lengths. Okay, so in step 6, what I'm going to do is use the expression for AC, which is 2x, and plug in the value of x, which we found was 2. So 2 times 2 is 4. Great, so the length of AC is 4. The length of line segment CB we're given is 8x. With x being 2, I can plug that in. 8 times 2 equals 16. Great. Okay, so we use the segment addition postulate, but the last thing we need to do is to check our work. So if I add up 4 plus 16, it gives us 20, which was the total length of line segment AB. Great, guys. Okay, so let's say you've been working out since you hurt your foot and you're feeling a lot better. Your foot's all healed. So you're still at Spring Woods and your friend is at Burger King, and you again decide to meet in the middle. This time, you meet exactly in the middle, which means you traveled the same distance to get to this point, the middle, as your friend traveled from Burger King to meet with you here. Okay, this point has a very special name. Again, if I represent the distance from Spring Woods to Burger King as a line segment, I have this point M, I'm going to call it point M, where we met, where you and your friend met, in between the two endpoints. But it's not only in between, it's exactly in the middle. And this point is called the midpoint. It's exactly in the middle between the 2 points. You see I use the word mid in both midpoint and middle to represent it's in the middle exactly between the 2 endpoints. Okay, great. The midpoint is also exactly halfway between the 2 endpoints. It means the same thing as being in the middle. Okay. So let's compare point C to point M. In our first example, we had a point C which was just between endpoints A and B. But now we have point M, and that's the midpoint exactly in between, exactly halfway between. But it's still a point in between. So there are many points that are in between endpoints A and B, but only one midpoint. Okay, so let's remember that, only one midpoint, which is still between the endpoints. Okay, one last way to describe a midpoint is that it cuts a segment into 2 equal halves. Okay, so I know that line segment AM is the same length as line segment MB. Okay, so when segments have the same length, they are called congruent in geometry. We use the congruent symbol to show congruence in writing, and we show this congruent symbol to show it as an equation, as an expression. Okay, great. We also use these dash marks called tick marks to show that 2 segments are congruent in a figure. So to show that line segment AM is congruent to line segment MB, I show you these tick marks. Okay, great. Let's use what we've just learned to solve a problem. So we have midpoint M, and these tick marks tell us that line segment AM is congruent to line segment MB. Okay. Step 1 of this problem is to create a relationship between line segment AM and MB, because what I'm trying to solve is the length of both AM and MB. Okay, so I have a relationship here, and that's always what I want to set up first. What is the relationship between the line segments? I know that they're equal to each other because these tick marks tell us they're congruent or have the same length. Okay. My next step, I can plug in the expressions that are given for the lengths of each of the line segments. AM has the length 3x plus 3. It's an expression with variable x. And so does MB. It's an expression with variable x given by length 4x. So I'm just going to plug in those expressions in place of the line segments. Great. Now I can solve for x. So step 2, I'm just going to collect the x's on one side. So I'm going to move the smaller number of x's over the larger number of x's, which means I'm subtracting 3x from both sides. Okay. So that gives me, when I've crossed out 3x on this side, it leaves me with 3. and 4 minus 3 is 1. So 3 equals x. Great. Or I can flip that around as x equals 3. So our last step, remember, we want to solve what the length is of the line segment, so I'm going to plug our value of 3 back into the expression. First, AM, we have 3x plus 3. When I plug 3 back in, I have 3 times 3 plus 3, which is 9 plus 3 equals 12. Okay, for MB, I have the expression 4x. So when I plug 3 back in, I have 4 times 3, which equals 12. Okay, well this indeed, we have line segment AM is equal to line segment MB. Their lengths are equal, which is 12. Great. Okay. All right, one more thing before we move on to the last thing. We found that the tick marks in our last example told us that line segment AM is congruent to line segment MB. But I don't have to have a join line segment, two join line segments to show that they are congruent with tick marks. I can have separated line segments, as I'm showing here, to show that line segments are congruent. So this, because I have a tick mark here and a tick mark here, that means that line segment DE is congruent to line segment FG. Great. Okay. The other thing is that I can show two different pairs of line segments, WX and YZ, and they have the same number of tick marks. They have 2 tick marks on each of the segments. And when I have the same number of tick marks on 2 or more segments, that tells me that those segments are congruent. So line segment WX is congruent to line segment YZ. But just as importantly, it tells me when I have 2 line tick marks here and 1 tick mark here, it tells me that the DE is not congruent to WX. Likewise, YZ is not congruent to FG. Okay, one last thing before we close out for today. Let's talk about midpoint one more time. So a midpoint is a point that cuts a segment into 2 equal halves. We already have talked about that. But I can replace the words cuts into 2 equal halves with the word bisects. Okay, so bisect means to cut in half. Great. So a midpoint does that, but what else bisects a segment? Well, I could have a line segment that bisects a segment, a ray that bisects segment AB, and a line that bisects segment AB. The important thing to remember is that all 3 of these figures are bisecting our segment AB at its midpoint, M. So these 3 figures are called segment bisectors because they're bisecting a segment, or they're cutting the segment in half. Okay, so go ahead and take a moment and write down segment bisectors using these examples in your notes. Great job, guys. Great. So in review, guys, you found the length of line segments using a point in between points, using the segment addition postulate. You found the length of line segments using the midpoint, and you identified segment bisectors. Great work today, guys.